Lesson 25, Solving Systems of Inequalities. So if we were going to take this lesson in class, I would have put up an equation or an inequality and asked you to graph it. And then I would have put up a second inequality and asked you to graph it. And then I would have put up a third inequality and asked you to graph it. But since you're not here and you're watching this video, the discussion we would have had at class, I'm going to try to have right now. So let's start first with this equation right here. We want to graph that inequality. To do so, there's many ways to do it. It's whatever works for you. Some people will have to get it into slope-intercept form, which means we're going to have to subtract the 3x, so 12 minus 3x, or if you prefer, negative 3x plus 12, so that way it's closer to that slope-intercept form, and then divide by 2, negative 3 halves x plus 6, and they'd have to graph it that way. Someone else might say, oh, no, we could just go straight to x and y intercepts. X-intercept, we know the y is 0, so that means 3x would have to match up to the 12, and for the y-intercept, the x would equal 0, which would mean from up there, the 2y would have to be 12. And that would tell me that the y is 6 and the x is 4, where the other one is the slope-intercept. So let's go ahead and do that. Graph the 6. 5, 6, right? There's our point, right? And now, according to the slope, it's down 3 to the right 2, down 3 to the right 2. Hey, notice the x-intercept is a positive 4. And then we would just kind of continue doing this for however long we want to continue doing it, as long as we make sure we keep using the same slope. If you need to, you can go up 3 as long as you go to the back 2. And then, since this is a less than equal to, we draw in a solid line. Do you recall when we might put in a this is just not a very good line. Let me start definitely there. One, 2, 3, 4, 5, 6. Oh, wow. That explains it. I put those dots in the wrong spot. There we go. Never mind. I even made the comment about, hey, notice that's at 4. And then I didn't actually get it through 4. Okay, so there we have that part. Now, there's got to be a shading thing to this. Oh, the other thing to remember. Wow, big things. Solid line on the bottom says make it a line. If it would have been just been this, we would have went with a dash line. Okay, that's why I got it to be a solid line. Now we got to figure out which way we're going to shade. There's many different little reasons to do a shading one way or the other. How you do that, depending on the way the equation is set up. If it's signing, the water's going to be on what type, whatever. Okay. For me, I always find a point that is not on that line to do as a test subject. When possible, I like to use 0, 0. If I take the point 0, 0, and I plug it into that inequality, does that make a true inequality? Is 3 times 0 plus 2 times 0 less than 12? Yes. Okay. Since I know I'm going to be graphing multiple inequalities, I'm just going to put some arrows on here to remind myself which way this thing's shaped. So there's kind of my graph of the 3x plus 2y is less than or equal to 12. I know I'm going to be shading down below. So if I was shading the whole thing, I would shade all of that to the bottom left. All of it. Now I got to do these other two. I have this handy dandy little guy right here. X is greater than x is greater than or equal to negative 2. That means there's no y. If there's no y, there's no y-intercept. If there's no y-intercept, it means I have a vertical line. So x greater than or equal to 2 is a vertical line that's going to get shaded. And if I do a vertical line, I'd have to do it at where? The negative 2, which is this line right here. Bad choice of colors. Let's change that color. We need something a little more dynamic. It's going to work. That'll show up a little better at least. Okay, and then extend it. And like we did last time, I need to figure out which way to shade. X is greater than or equal to -2. So if I think about that, -2, -2, if I put a 0 in there, 0 greater than -2, yes. So I'm shading to the right. So if it was just these two graphs, I would say my answer is everything that's here, and I would refer to this as being an unbounded, because down here in the bottom, there's nothing blocking it in. So there's my region for those two. But guess what? We know it's not just those two. We have this third set of this third inequality. Y is greater than or equal to -3. Okay, there's no x. No x means no x-intercept. No x-intercept must be parallel to the x-axis, means it's a horizontal line. So y greater than or equal to -3 is a horizontal line. And it'll be solid. And we're going to make it, I don't know, purple. Okay, so 1, 2, 3, solid line going this way, right there. I do my check. I pick a point not on the line myself, or I can just think, oh, greater than -3 has to be up. Okay, so now, as I got those graphs, I want to know where are all the places that could be answers to this. Where's all my shaded region? And my entire shaded region is everything inside this little triangle here. This is my answer, this shaded region. Voila. Woo, piece of cake. Okay, so now, typically what we do then is we try to evaluate a bivariable function, which means I need to have points to put into it. And what they recommend down here is we need to evaluate this bivariable function. Bivariable meaning that it's going to have an x and a y that goes into it to get us a value. Bivariable functions determine the max and min. So somewhere in all of this, there are a ton of different points that we can plug in there, and we're looking for a max or min. There is a rule, a law, a theorem, whatever, that says something along the lines that all you need to do is look at the vertices of the boundary region. So if I look at these vertices, I've got a 6, -3 there. I've got a -2, -3 there. And I've got a -2, 9. Yep, -2, 9. So those are my 3 points that I have to work with. So I have f of -2, 9, f of -2, -3, and f of 6, -3 that I want to stick in here to see what values I get. So if I put the -2, 9 in for the x and y, I get a 7 times a -2 minus 2 times a 9, which gives me a -14 minus a -18, gets me a -32. And if I put the -2, -3 in there, I get a -20, a -14 plus 6, which would give me a -8. And then if I do the other one, 6 and -3, I get a 42 plus a 6, I get a 48. So now, all I gotta do is figure out what's my max or mins from those. Well, the 48 is the only positive number, so it's definitely in the max. And when I look at my negative numbers, the more negative is, that's my min. So there's my max and my min. So when I'm solving a system of equations, inequalities, I graph them, and my answer is where they agree at for shading. If they don't agree on a shaded area, there's no solution. If they agree on a shaded area, well, then I start looking at the corners or the vertices of that, what we call the shaded region. So, graph, shade, find vertices of shaded region, Evaluate bivariable function. I wonder what this all says if I recognize handwriting. Graph, shade, vertices, shade region, evaluate bivariable function. There you go. That's all we have to do in this particular lesson. Got to be able to do those things. And I think you can do it. Oh, you probably want to know. Lesson 25. Page 110, problems 9 through 22.